Hello everyone, welcome to my YouTube channel. Today we are going to discuss about binary search. Okay, so let's get started with it. Okay, see, I will give you an example and demonstrate you what actually the binary search is. Okay, how it works. Okay, let's take an example of array. Okay, this is the array of numbers. Okay, we will use two pointer approach. First pointer will be here, second pointer will be here. First pointer is named as start point and another is end point. Okay, now in this algorithm we are supposed to calculate the midpoint. Okay, now see, array are indexed from 0 1 2 3 4 5 6 7 8 9 10 up to 10. Okay, now we are supposed to calculate the middle point of this. Okay, so how we will calculate lower index plus higher index divided by 2, lower index plus higher index divided by 2, so 0 plus 10, which is 10, divided by 2, which is 5. So it will be over here. Okay, so this is called as midpoint. We are searching for 89 in this array. Okay, so see, human can easily identify that 89 is located in the array, but for a computer it is very difficult to identify whether it is present in the array or not. So how the computer's approach is, I will tell you. First of all, it will calculate the midpoint. Okay, so midpoint is 30, so it will compare 30 with 89. So let's compare 30 with 89. Is 89 greater than 30? Yes. So the element will be present on the right side. So the element will be present, 89 will be present on the right side. Okay, so in that case this start point will be shifted here. Okay, this start point will be shifted here. Okay, let's go ahead. It's here. Now again it will calculate the midpoint. Okay, so in this case the index of that element is 6 and this element is 10. Okay, so 6 plus 10, which is 16 again, and divide by 2, 8. 8 means this, so mid is over here. Okay, now it will compare 82 with 89. Is the element equal? No, it is greater. That means on the right side. Okay, so the element is present on the right side. Okay, so in that case this pointer will shift towards 89 like this. Okay, here. Now what we will do, again same approach will be followed. The index is 9 and index of end point is 10. 10 plus 9, 19. 19 divided by 2, again 19 divided by 2 will be 9.5, and it will be rounded off to the lower value. Then it will be 9. Okay, so it will compare this 89 with this 89. Is the value equal? Yes, definitely the value is equal and the search is successful. Okay, so the search is successful. We could say that this element is found in the array. Okay, now we'll do one more example. In this. Okay, let's take a second example. In the second example we are going to search 25 in this array. Okay, same approach will be followed. This is my start point, this is my end point. Okay, so and the array is array index is from 0 to 10, same. Okay, the element is changed to 25. Now let's start the uh, algorithm. In that case, first we are supposed to calculate the midpoint. Okay, so this is my 0th index and this is my 10. So 0 plus 10, 10 divided by 2, which is again 5. So my midpoint will be over 30. Okay, then I will compare 30 with 25. Is it greater or smaller? See, 25 is smaller than 30. So this array will be discarded. Okay, this array will be discarded and we are supposed to search in this only. Okay, now in this case the end point will be shifted towards 29. The end point will be shifted towards 29. See how it is shifted towards 29. Now again it will calculate the midpoint. In this case the index is 0 and this is 4. 4 plus 0, 4 divided by 2. So 2. So midpoint will be here 20. Is 20 equal to 25? Is 20 equal to 25? No. Okay, but it is greater. So that means it will be on the right side. Okay, so in that case we are supposed to shift the start point. Okay, we are supposed to shift the start point. Where we will shift? Start point is shifted to mid plus 1. Start point is shifted to mid plus 1. So this pointer will be shifted towards here. Okay, like this. Okay, now next would be what? See, Next algorithm continues. uh, this is my 3, index 3, and this is my 4. 4 plus 3 7. 7 divided by 2, which is 3.5. And what I will do, I will take the lower one, 3. Okay, C3. 25 is equal to 25. That means I can say that search is successful. I can easily say the search is successful. So in this manner, we have successfully found this 25 in this array. Okay, see why we are supposed to use binary search. Binary search, in binary search number of iterations are less. Okay, in binary search number of iterations are less. Okay, now see, I will give you some formulas which will help you. See, first of all, while we solve array of mid, when we talk about array of mid, will be equal to start plus end divided by 2. Okay, so these are nothing but the indices. Okay, start index, end index divided by 2. Okay, so this is the element of array of mid. Okay, now let's see how we can apply it in this. We'll take one more example. See, in this case we have an array. We are supposed to search 21 in this array. We are supposed to search 21 in this whole array. Now how we will go ahead? First of all, we will calculate the midpoint again. Okay, so this index is 10, this index is 0. 0 plus 10, 10 divided by 2, again 5. Okay, mid is here, so it will compare these two elements. Okay, so 30 and 21. 21 is smaller than 30. Okay, so we are supposed to discard this array. Okay, now end point will be shifted to mid minus 1. Okay, let's shift it. Okay, yeah. Now let's continue the algorithm. In this algorithm, what we are supposed to calculate, again we are supposed to calculate the mid. Okay, in this index is 0 and this index is 4. 4 plus 0, 4 divided by 2, it's 2. Okay, the mid is here. We'll compare this element with this, 20 with 21. Okay, so can I say 21 is greater than 20? 21 is greater than 20. Okay, so the search element should be ideally on the right side. So this part is discarded, and I am supposed to shift this start point over here, mid plus 1. Start is shifted to mid plus 1. Okay, so over here. Now look here, I have a start point which is at index 3 and end point at index 4. So 3 plus 4. 3 plus 4 would be 7 divided by 2. 7 divided by 2, 3.5 it will come. So we'll take the lower one, 3. That means 3. 25. Is 25 equal to 21? 25 is not equal to 21. So in this, see, almost this start and end are closer. Okay, so element is not found. In this case, this 21 element is not found in this array. Okay, so I hope this concept is clear to you all. Whenever the element is not found in the array, the index won't be written to the program. Okay, now see, linear search. Why we should avoid this linear search? Suppose if this is the array, and we are searching an element. Okay, 33. Okay, we are searching an element 33. How many iterations it will take? 1, 2, 3, 4, 5, 6, 7 iterations. But while we compare, in binary search, number of iterations are less. In binary search, when we compare, the number of iterations are less. So we are using this binary search approach instead of using this linear search. Okay, as you could see, in linear search we are searching 37th element. How many iterations it will take? See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, step 0. Okay, 12 steps it will take, and in this case it will take almost 3 steps. Okay, 3 steps it will give you the answer directly. So this is why the binary search is more effective compared to linear search. All right, now I am giving you a practice question. Let's copy it down quickly. I am giving you a practice question. I want the answer for this question in the comment box. All right, that's all for today's session. See you in the next lecture. Till then, bye bye. Don't forget to subscribe my channel. Have a good day.